Hello YouTube viewers, welcome to my show Science Thursday. In today's episode, we're gonna continue our robotic series, and today we're gonna talk about hydraulic systems. So let's dive right into it. Now question becomes, why the heck you want to use hydraulic? First of all, it's simple. Now here's the fact, like if I have to take three major system of robotics, first is motor, second is pneumatics, basically compressed air, third is hydraulic. So hydraulic would be in between. Basically it's not as simple as compressed air, but it is not as complex as stepper motors, stepper servos, and driver circuits and all that. So it is relatively simple. That is one very big advantage, and it is very powerful. Like it is the definition of power. Basically hydraulic power, it's on a whole different magnitude. Like there is no motor circuit that can even come close to the power density of these puppies. Like these is very powerful. To give you a context of this, think of this way, like if you try to have a motor here in this axis and try to replicate its power, yeah, the motor will become bigger than the arm itself. So it is very powerful and it is very controllable. That's how you can see like people utilizing this without advanced computer controls. They can just use knobs, levers, valves and all that, and they can control it. It is a very manageable beast. Like it is very powerful. Like, you have to understand, like there are press that can produce like 1,000 ton to 10,000 ton. So there are things that are very powerful, but it is a manageable beast. So first and foremost thing, the how you see hydraulics in your day-to-day life is basically hydraulics cylinder. Now the cylinder is very powerful. Like you can see them into bridges also, because many bridges now have hydraulic dampeners. Basically they have simple things, and they have a small hole from which hydraulic fluid will be forced through. It will heat it up, like it will go as hot as like 100 to 200 degrees Celsius. But this can literally, the deck of the road can vibrate, and this can handle lot of newtons. Basically it can absorb a lot of physical shock. So they are very powerful. Like there is no discussion about the power ability of this. Like if this puppy can't handle it, there is almost nothing that can do that. So it is very powerful, and it is simple plus reliable. Like in terms of reliability, these probably exceed almost any other system we have. Like in terms of, let's say, motor robotics and all that, we have to make them in a clean environment. We have to keep them in a clean environment. Like, of course we put dust guard, as many covers as we can do, but these things we utilize them in construction site, we utilize them in mining industry. So you have to understand, unclean environments, unsanitary environment, but somehow these people these still work. Like they are very robust and reliable. And in terms of precision, they are precise enough. Like they can, they do not have suffer them from the same problem of pneumatic system, where you have to only two settings, either fully extracted or fully interacted. Like they have much more control. Like you can be like, okay, stop, no, little bit back. Like, and some people have shown some extreme ability where using basically excavator, they are just pressing a lighter cigarette without breaking it. So it is precise enough. Okay, what the heck drives that? Like in case of air, we have very simple thing. You don't have to think about it. By any air compressor, it will work as long as it has enough capacity and pressure. It will work. However, when you are talking about hydraulic, you have to understand this. Hydraulic simply means liquid. Liquid are by design, by inherent nature, uncompressible. Like most of the liquids are uncompressible. Like oil and water, they are flat out uncompressible. That simply means if you have 1 liter of, let's say, oil, and you take that, or let's say 1 liter of bottle, and you put it into deepest depth of ocean, it will still be 1 liter. Like if you did that with the air, of course it will be compressed. You did that with many solids, that will be also compacted. But in terms of liquid, yeah, flat out, nothing will happen. And that's why we generally when you have submergibles, basically unmanned deep sea vehicles, they are generally filled with oil, so they can go very deep, without requiring pressurized hull. So it is used in that way. So you have to understand, we cannot use compression here. However, we can utilize the luxury of pressure. So you will have a motor like this. You will have basically 2 psi from your reservoir coming here. Nothing fancy, is just coming here, 1 liter per minute, let's say, and outside it will still go 1 liter per second. However, the psi would have been gone from from 2 psi to 200 psi. That's up to you. Depending on design, some motors can create even higher pressures, and some pumps have rated as 10,000 psi and all that. So you have to understand that we convert rotational energy into hydraulic pressure. That's what's happening. That this is the heart of almost every hydraulic system you see, where you convert the rotational energy, be it from motor, be it from a generator, be it from a diesel system, or whatever have you. We convert the hydraulic and basically rotational energy into hydraulic pressure. That hydraulic pressure is converted into useful motion by hydraulic cylinders. So that's what we do. Now there is another advantage to this because of the inherent design principles and all that. It is very high in terms of power to weight ratio. Think of it this way: like if I give you hydraulic motor that is like 100 horsepower in terms of output, you can hold it in your hand. There is no 100 horsepower motor that you can hold in your hand. Like again, you can say like bit bigger, or you have to have Schwarzenegger hands, but you get the point. It's like in terms of power to weight ratio, it's mind-bogglingly different scale. Like these motors, like they are big. They are generally used for very heavy mining equipments and all that, and they produce like insane amount of horsepower, like 1000 horsepower, 2000 horsepower, 5000 horsepower, sometimes even higher than that. So in terms of hydraulic pumps and pumps, and basically they are interchangeable in some designs, not all of them. Most of them can be interchanged because of the hydrodynamics itself. So you can have a pump or a motor, and both of them are ludicrously high in terms of power to weight ratio. So you can have an excavator that has like this big diesel engine, like big powerful engine, and then you have this tiny pump. So hydraulic pumps are the heart of the system. Then we come to the aspect that you must be familiar with the fact that hydraulics is kind of old. Like we have been utilizing this for almost 100 years, more than that. So what can we expect in the future? Basically, you have to understand in terms of efficiency, we are quite efficient. Like we are there, like we are in the 90% range. But there is one inherent limitation. Like the most of the complex hydraulic system utilize what we call valve box, basically something like this. Now where you have valve control and all that. Now we know how to build this, but problem is because it's a fluid and it's flowing, you want to give it a smooth curve. You don't want to give it a jagged edge, like tick 90 degree now done this. Just reduces a little bit of efficiency. It acts as a flow limitation. So utilizing 3D metal printing, because you have to understand hydraulic fluid will be still under pressure here also, because it still would be like 100 to 500 psi, whatever the circuit system is. So they want to use 3D metal printing to make a smoother valve block. This will add a bit more efficiency. And again, because right now we cannot do very complicated system, because we can't drill like inside the metal within another hole and all that. So there is a limitation with CNC machines. If we can make a very high level 3D strong, like in terms of robust system, we can make very complicated systems, even more complicated than what we have right now. So 3D valve mechanism is like it's a one way where research is being done to make it more better. Then we come to the aspect that is happening in a slower scale, but it is happening brick by brick, day by day. It's that we are making compact design possible. Like right now, you can just go in the shop and buy a motor system which has a hydraulic pump integrated into it, and get whatever pressure that you want, like 15 psi, whatever have you. But here's the deal: if you told to any machine shop that was dealing with hydraulics, this was like 50 years ago, they will laugh at you. Like not because like physics is stopping it, it's just that we did not have the enough know-how, enough knowledge of fluid dynamics and all that to make it compact. Now this is one easy example. Second, think of it this way: like planes also utilize hydraulics extensively. Now in customer aviation, it's not a big issue. However, when you're talking about fighter jet, space is in a premium. Basically, fighter jets are very compact. So the older system was like, again, you have your motor, you had your like pumps, and then you have cylinders on the wing surfaces and all that. Now the newer system is that they will have a compact unit itself, completely enclosed. All they will send to it is electricity. They will have the motor, pump, and the hydraulic cylinder in one unit. So that way it is very compact, and like they just have to make sure the space is there in the basically winglets, and they don't have to like have entire complicated plumbing and all that. So there are improvements in terms of making it more compact, making it far more efficient using 3D printing. So there is still some room of improvements. Now again, if this is so good and awesome, is there any side effect to it? Of course, every system has side effects, so this also has the side effect. It has side effect of being inherently slow. Now why the heck it is inherently slow? Basically it has to be slow. Think of it this way: we are doing many people call basically system, the hydraulic system, as a force multiplier. Now that is technically true, but you have to understand there are no free lunches. You cannot be like, okay, I'm putting like 500 newtons and I'm getting 5000 newton on the other end. That's not how physics works. So what's happening here? Basically the easiest way to understand this is, think of it this way, in terms of electricity. Basically same way you take a voltage, you increase the voltage, you reduce the ampere, same is happening here. So we generally the way we describe it is in travel distance. So let's say you have a hydraulic car press, and you're like you're doing this. So you the small cylinder that you have, the that is on your end user end, you are moving it like, let's say 10 centimeter, but the car end, again, you are barely exerting, let's say 50 kilo, but it's exerting 500 kilo on that. So what will happen is like 10 centimeter of travel will be turned into 1 centimeter of travel on the other end. So that's how it's working. Basically, that is the reason, because that 100 horsepower to 500 horsepower basically engine there, it cannot magically create enough power that you can just remove a tree like that. It does not have that power. So the motor does that, and over time it's like okay, it adds pressure over time. Now again, when I'm saying over time, I do not mean like over a course of hour, I still mean in seconds. But you have to understand that like electric motor can apply that much power instantaneously. Not instantaneously, but you get the idea. Like inherently this is slow because you are like piling things up on top of it. Then in terms of precision, anybody who has seen this, how much effort it takes to just get it just right. Now again, experience helps you with that, but you cannot never expect this to be as precise as a welding robot generally used for car manufacturing. It will never be as precise. Not only you have to understand that by design it's taking time to do whatever it has to do, it also suffers from expansion and contraction. So basically temperature based. The oil itself is uncompressible, quote unquote, but it does change its volume if temperature goes up or down. Very little, but it does change temperature by default, making it, let's say your during daytime your robots were like very precise, awesome. In the morning everything was awesome, but during night you started to run, temperature went down, the robots are not doing what they're supposed to do. And it could be very subtle, and there are many precise systems where you can compensate for that, but you have to understand this, like by design it cannot be as precise as a motor system. And in terms of piping, now again, electrical motors and all that, they also have issues with wiring. But you have to understand, when you're talking about wire, you do not worry about wire as in like what will happen if I bend it. All you have to worry about is like, is the insulation intact or not? That's the only thing you have to worry about it. Again, you have to make sure that it's not turned outside or something like that. But here you have to make sure the bend radius is maintained, same as pneumatic system, because if these puppy are kinked, basically you folded it too tightly, it can explode. And I do not mean it in a jokey way, it will explode. It has that kind of pressure, and they also wear out. You can have a motorized robot system with wiring and all that. That wiring could last for 20 to 30 years. Here in terms of hydraulic hoses, they are generally changed every 5 to 10 years. So you have to understand, piping system on these puppy are a very tedious job. Basically, it's not something that you put and forget. You have to be keep checking it regularly. If you are lucky, if it bursts, all it will do is leak out pressure. But be mindful, if anybody is right in front of it, it will injure. It will not explode, but it will injure the person if in front. So there are certain problems and limitations with this. So this was my presentation on hydraulic system. I hope you liked it, learned from it. In that case, please click the like button. If you didn't like it, didn't enjoy it, I would urge you to press dislike, press it twice to show me your extra disappointment, and please leave a comment because I reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.